Assalamu alaikum. This is experiment number 4. We are investigating the relation between the magnetic field due to a current in a straight conductor. We will be varying very different parameters and measuring the magnetic field for each one of them. But before doing this demonstration, we will be explaining each part of the devices that we have here, why we have them, why are they there, and what will be the effect of removing them, adding them, and then we will do a complete demonstration for the experiments. You are supposed to take all the readings from the experiment. By the end of the experiment, you should be able to write your reports that we expect you to submit in Blackboard, containing the data, the calculations, as we usually do for our ordinary experiments. So this is an experiment where we have a current passing through a conductor, and we will be measuring the magnetic field at different positions due to this current. We will be varying the amount of current that is passing through the wire, and of course we will also vary the distance and so on. And to be able to do this, first we have to generate the current, and to have a current generated, we'll be using our voltage source here, which has different outputs. We will be using one of them today, which has an output of 0 to 15 volts and 0 to 5 ampere current. We are interested in the current, and that current will be connected and passing through the wire itself. But because the current is very small, will not be enough to generate powerful magnetic field that we can measure easily. And to do that, we will raise that current and make it much higher than the 5 ampere that we have here. And to do that, we will be using what we call a transformer. Of course, you know what's a transformer by now. Transformer will change the voltage from one level to another voltage level. And while doing this, of course, it will either reduce the voltage, increase the current, or increase the voltage and decrease the current. So this is known as a voltage transformer. Basically, it is made of two coils. This is one coil and this is another coil. Nothing is connecting them except this core, which will connect the magnetic flux that was generated due to the current passing through this coil into another coil with no electrical connection. The connection will be only through the magnetic flux that will be passing through the core that we are having here. Now we have a current passing through this, and you can notice that these are thin wires, and the wires are designed in such a way that they can stand more than the current that we have here, which is the 5 ampere. They can stand something like 10 amperes or 12 amperes with this, but we will be having maximum of 5 ampere passing through. Okay. Now this current, we want to make it much higher and bigger, and to do this we are having different ratios between number of turns in the primary and the secondary. Much higher number of turns in the primary compared to the secondary, and because of this we will have much higher current in the secondary. And you can notice that in the secondary we have much bigger size of wire, and that is because the current that passes here will be much higher than the 10 ampere that we started with, or 5 ampere that we started with. Now the current here can reach up to 100 or 150 amperes. We will be going from 0 to 100 ampere. So let's say 5 ampere passing through this, generating 50 amperes or 100 amperes here, depending on how many number of turns here compared to the number of turns that we have in the second one. Okay, so this will be doing this for us, and this is our transformer, and this is exactly a replica of this. So current is coming, we are increasing the amount of current, making it much higher. We said we will go up to 100 ampere, and that ampere will go through this, and you can notice that this is a very thick wire that can handle that much current, and then this will generate a magnetic field. Of course, we know according to the right hand rules that there will be magnetic field that is rotating around the wire that we have, and we will be measuring that magnetic field. Now before measuring the magnetic field, we need to measure what is the amount of the current here, or we need to make a relation between the current that is here compared to the current that is in here. The easiest way is to measure this current, but if we try to measure the current right away from here, it will be very difficult because the amount of current passing is very, very huge. 100 ampere, we are saying it's not safe to work with it, and any mistakes we make can create a lot of problems. And just to protect us, we will not try to measure it directly as we usually use an ammeter to do it. Instead of doing that, we will be using what we call current transformer. This is a replica of this. This is just simply one coil like this one, known as a current transformer because it does not have a primary. Its primary will be the amount of current that's passing here, generating magnetic field. That magnetic field will be generating current in this new transformer now, which is a little different than this one because it has only one coil, and we are calling it a current transformer. Now this current transformer measures the amount of current that is passing through this, and the relation between the current that is passing through this and the current that will be measured by the current transformer is 100 times. So if 100 ampere passes through this, you will be measuring only 1 ampere, and the multiplication will be, of course, the 100 that we have here. So we are using just a regular ammeter to measure the current, and the current here is simply 100 times or 100ths of this current that is passing through the wire. Now we have very high current. We are safely able to measure the amount of current that is passing through. We said 100 is equal to 1 ampere, and 1 ampere will be 0.01 of an ampere passing through the transformer. Okay, now we need to measure the magnetic field, and to do the measurements for the magnetic field, we need first our device that measures the magnetic field, and we call this one a Tesla meter. It measures the magnetic field at the tip of this probe, and that is parallel, okay, to the probe that we have here. And because of this, we call this probe an axial probe. It measures parallel to the axis at the tip. If it is parallel toward the direction of our probe, then it is positive one. If it is opposite, then it will be a negative value, and it is displayed in the screen that we have here in our Tesla meter. So here we don't have anything running, no current is there, so the amount of current that is passing through the wire is 0, which means the magnetic field that you are measuring here is equal to 0. So the first step is we calibrate our device to make it equal to 0. So we calibrate it using this, changing this until we get the minimum we can get. So I'm getting 0.02 ampere, 2 milliteslas, and this is a minimum value for my measurements. And then I will switch my power on, and once I put a current, then what will happen is that the magnetic field will be generated due to the current passing through the straight conductor, and this magnetic field I'm measuring using my Tesla meter. So I will be varying the current, measuring it here, making sure according to the table that we have it is varied 0, 10, 20, 30, and so on. And at the same time, we will be measuring the magnetic field, of course, using our Tesla meter. So we'll do the same thing, of course, this, but now we need to set first our probe at a specific distance, and we are choosing to put it at 1 centimeters. So I'm measuring the distance from the center of this wire to the center of the probe to be 1 centimeter, and we are making sure that it is parallel, perpendicular to the wire that we have here, and parallel to the magnetic field at the position that we are measuring. So in this case, the field is rotating, and at this point it will be either this way or this way, depending on the current, if it is going upward or downward. And the magnetic field, of course, is perpendicular to this. If I move it out, then it will be perpendicular to this way, and so on. I'm making sure that it is parallel to make sure that I measure the maximum value for magnetic field. And the procedure is very easy. I will be varying the current, measuring the magnetic field according to the table that we have, and you have to make sure that whatever measurements we are doing now, you are putting it in your table, because this will be needed for preparing your lab report. So let me put, according to the table here, we have for 0, it was equal to 0. We noted that. And now I will put 10 ampere. So I will be varying this until I get a 10 ampere current, and this is a 10 ampere current, and then I will be measuring the amount of magnetic field that we have here, and it is equal to 0.2 millitesla in this case. So let me just make sure that it is exactly equal to 2. It's a little bit more now. So this is equal to 2 exactly. Sorry, 10 ampere, and that is 0.2 milliteslas in this case. Okay, and now we will vary the current into 20 ampere, and this is my 20 ampere according to the table that we have, and for 20 ampere we are getting nearly 0.41. It is a little bit more, so let me just make sure that it is okay. So we are getting something like 0.39 milliteslas. I will go for 30. Okay, so this is my 30. Okay, so this is my 30, and I'm getting 0.6 millitesla, 0.6 millitesla in this case. Now I will go for 40. This is my 40, and I'm getting 0.8 millitesla, 0.8 millitesla. I will go for 50. Okay, so this is my 50, and I'm getting 0.99 millitesla, 0.99 millitesla. I will go for 60. So this is my 60, and I'm getting 1.2 millitesla, 1.2 millitesla. This is 70, and I'm getting 1.4 millitesla, and this is 80. This is 80, and I'm getting 1.59 or 1.6, you can say, millitesla in this case. And the one before the last, this is 90, and I'm getting 1.8 millitesla, 1.8 millitesla, and this is the last one. So we are putting 100. Okay, you can notice the noise. This is due to the high current that we have, and we are seeing 2 millitesla in this case. Okay, 2 millitesla due to 10 ampere current passing, or 100 ampere in the wire passing. Okay, so this is the first table, and you have to make sure that now you don't touch anything here, because this is very hot, because 100 ampere was passing through it. So we have to make sure that nothing is we always think of safety first before we touch anything. Now the second part, which is table number 2, requires me to change the distance for a specific value of current. I will be changing the distance 1 centimeter, 2 centimeter, 3 centimeter until 10 centimeters, and I will be measuring the magnetic field due to each one of those. Now we are setting a current of 100 ampere, so we will put this into 100 ampere. So this is what I ended up with. So this is my 100 ampere current. Okay, I'm setting it exactly to 100 ampere, and I know that this is 1 centimeter. We started from there, so now I will start moving from this position every 1 centimeter, and I will be measuring the magnetic field for each one of them. So for 1 centimeter we are getting 2 milliteslas, we said, or 1.98 milliteslas, and then I will go now 1 centimeter from that. Okay, so I will be moving 1 centimeter, so this is 2 centimeters if you want to, and this is 0.9 millitesla or 0.89 millitesla, and this is 3 centimeters, so I'm getting 0.54 millitesla. This is 4 centimeters, and I am getting 0.37 millitesla, and this is my 5th one. I'm getting 0.27 millitesla, and this is my sixth one, 0.2 millitesla. 7 is 0.16 millitesla. 8 is 0.13 millitesla, and this is 9, 0.11 millitesla, and the last one is 0.09 millitesla. Of course, you can note that it is decreasing inversely proportional to the distance. So as I'm going away from the wire, it is getting we are getting a much lower values. When we come closer to it, we are getting much higher values. Of course, it is simply 1/r relation according to the equation that we have. So this is the last equation, the last table for the experiment measurements that we need to do. You need, of course, to do the calculations for each one of those two tables, and of course you will do theoretical values calculation and the percentage error and so on. And don't forget, by the end of the experiment there is a question which requires you to suggest what do you expect if we have a wire which carries, or two wires which carries current in opposite directions. So the current is going this way and then it is going down. So what do we expect the magnetic field to look like when we change the distance with respect to those two wires? Of course, the equations are given for you, so you can plot the equations if you want to, but you can also think of what we just did. We know that as we go away from this, it is a decreasing function. As we go away from this, a decreasing function, and same thing of course for this one. Now somewhere it will be adding, somewhere it will be subtracting, depending on the direction of the magnetic field that you are generating using those two currents. So we would like to see how do you expect it to be your magnetic field. And this is another case where we have two currents on the same direction. So current is coming this way, and then it is separated or divided into two. So one current is going down, another current is going down. So what happens now to the magnetic field? As I just said, we expect decreasing function as we go away from each one of them, but somewhere they will be adding, somewhere they will be subtracting. So now we can guess, or at least suggest, what we expect to have for the magnetic field. And this is in the questions that you have in your lab manual. So make sure you also try to predict what you expect for those, or if you want, you can use the two equations that you have in your lab manual, which are those two, and try to plot them, and they will give you, of course, exactly what is expected from those two. Okay, so whatever you want you can do. We just need the sketch for those two. Thank you very much for this demonstration. Make sure you submit your lab reports using Blackboard. We expect it to be submitted next week, of course, at the beginning of the class of your respective labs. Thank you very much, and see you next time.